Hey, hello everyone. So today in this video, I'm going to draw a tangent to the circle without directly using calculus. Now this video will prove very helpful to people who are just starting on calculus. So I have a circle here with its center at origin, and I want to draw a tangent to the circle at say this point x1, y1. Now let the equation of the circle be x squared plus y squared is equal to a squared, which means that the radius of the circle is a units. Now, a tangent is just a line, and a line needs at least 2 points for us to construct the line. Like, you cannot construct a unique line passing through a single point. For example, there could be this line which passes through this point, this line, this line, this line, and an infinite number of lines. But if you have 2 points, however, you can only draw one unique line through those 2 points. No other line can be drawn using these 2 points. So, at this point, there can be numerous lines which can be drawn. We are looking for this line, which is a tangent to the circle, which touches the circle at only 1 point. But there are numerous number of lines which can be drawn. So how do we pinprick that line? Well, what we do is, let's take another point, which is x1 plus some delta x. Well, delta x is some change in x with respect to x1, and y1 plus delta y, the same thing as x. Now, we can draw a line which connects these 2 points, just like this. However, this is not a tangent to the circle. No problem. Let us first derive the equation to this line, which is a secant. A secant is a line which intersects a curve at 2 points. So let's find the equation to the secant. Let's find the slope or gradient of this line. It would just be the difference in y coordinates divided by the difference in x coordinates. So difference in y coordinates is y1 plus delta y minus y1, and difference in x coordinates is x1 plus delta x minus x1, which results in delta y by delta x. Now, for the equation of the line, we can use the point slope form. We know the slope of the line, and we know a point through which the line passes. Let's consider this point. So y minus y1 is equal to the slope times x minus x1. Right? Now, these 2 points, they lie on the circle. This point lies on the circle, and this point lies on the circle. So these 2 points must satisfy this equation right here. So if I put these 2 points inside of this equation, it must satisfy, which means so x1 squared plus y1 squared is equal to a squared is true. And the same goes for these 2 points when put into this equation. So let's put those 2 points in the equation. X1 plus delta x whole squared plus y1 plus delta y whole squared is equal to a squared. Expanding this, we get x1 squared plus delta x squared plus 2x1 delta x, and the same thing for y1 squared plus delta y squared plus 2y delta y, 2y1 delta y is equal to a squared. Now we have this equation and we have this equation. Let's number this equation 1 and this equation 2. When you subtract equation 1 from equation 2, we get x1 squared minus x1 squared plus delta x whole squared plus 2x1 delta x plus delta y squared plus 2y1 delta y plus y1 squared minus y1 squared is equal to a squared minus a squared, which is 0. So these two get cancelled off, and we are left with delta x squared plus 2x1 delta x is equal to minus delta y squared minus 2y1 delta y. Now, let's come to what we were trying to do. We were trying to make a tangent at this point, but we needed 2 points to make a line. Now what if I make this point equal to this point? So if this point equals this point, which means that this point here, this one, it slowly comes here near to this point and it comes indefinitely close, so we get that nice little tangent there. So that's what we're going to do. We're going to make this point as close to this point as possible. So how do we get this point as close to that point as possible? Well, we need x1 plus delta x to be almost equal to x1. And from that we get that delta x should be almost equal to 0. And from here, the same thing, y1 plus delta y almost equal to y1. We get delta y, which is almost equal to 0. Now, putting those two values here, x1, 0, and y1, 0. Now, these two terms just cancel off, 0 squared and 0 squared. These two terms, however, do not cancel off because delta x and delta y are not exactly 0. They're approximately 0. So that does not make these two terms 0. However, squaring a very small number and squaring a very small number, which are close to 0, makes them negligible. That's why we have cancelled out these two. So we got 2x1 delta x is equal to minus 2y1 delta y, and we get delta y by delta x is equal to minus x1 by, this comes here, yeah, minus x1 by y1. So that is a replacement for our slope, which is here, and taking that, y minus y1 is equal to delta y by delta x, which is now minus x1 times y1, into x minus x1. We get minus xx1 plus x1 squared. Rearranging the terms, we get y1 plus xx1 is equal to x1 squared plus y1 squared. Now if we go back, we know that x1 squared plus y1 squared is just a squared. So let's replace this by a squared. Y1 plus xx1 is equal to a squared, and there we go, the equation of a tangent to this circle at this point. That's the equation of the tangent. So that is how we can take out the tangent to any curve at any point without explicitly using calculus. Now, why do I say that we have not explicitly used calculus? Well, when we say that this is indefinitely close to 0 and this is indefinitely close to 0, this is actually a part of calculus. So yeah, I hope you guys learned something new, and as an exercise, tell me the tangent to this curve, parabola, at a point x1, y1. See you later.